What are these fields? And how are these fields the fundamental blocks of all nature? Put it simply, a field is just a quantity assigned to every point in space. To understand why fields are so fundamental, we need to take a look at your hand at some fundamental particles. Everything in the world around us is made up of atoms. These atoms are made up of protons, neutrons and electrons. While the electron is a fundamental particle, protons and neutrons are made up of further smaller particles called quarks. Including the quarks and the electron, there are 17 such fundamental particles. These fundamental particles are broadly divided into the fermions and the bosons, where the fermions are the particles that make up all matter and the bosons are the force-carrying particles. Each of these fundamental particles has a quantum field associated with it. Wait, stop. I don't get it. How are these particles and these fields related? Think of the water surface as a field in its ground state. This means that its energy equals to zero at every point throughout space. However, it's interesting to know that a field's energy is never exactly equal to zero. Instead, it hovers around zero. This is due to the Heisenberg uncertainty principle and is called zero-point energy. Now, if you think of the water droplet as energy which is being given to the field, the ripples are the excitations of the field. And these excitations are what we perceive as particles. Okay, now I finally get that. But I remembered you also said you'd teach me something about the Higgs thing. What is that? The Higgs boson is just an excitation of the Higgs field, which gives the fundamental particles their inherent mass. And how exactly does it give them this mass? Let's imagine two drivers. Driver 1 is a regular person, while driver 2 is the typical movie driver. When driver 1 comes across a red traffic, he will stop. Driver 2 will probably ignore the signal and drive through. If we think of the traffic signal as the Higgs field and the two drivers as two different particles, we can say that while driver 1 interacted with the Higgs field, driver 2 didn't. Also observed that interacting with the Higgs field slowed driver 1 down. The real Higgs field works in a similar way. It imposes this kind of drag on particles which interact with it. And this drag is what we mass. Welcome to the world of quantum physics. There are dozens of things we still need to explore. So, stay curious, stay awesome. This is Nihil Sarangi, and this was my entry to the Breakthrough Junior Challenge.